Hello, everyone. So if this is all working the way it's supposed to, I think you can see me and maybe hear me. Um, my name is Bill. Ooh, there we go. It worked. I'm in my bedroom right now. I assume you're either in your living room or your office, or maybe you're also in your bedroom. We have hopefully gotten our shit together, and we are back for 2021. We obviously missed January. That's okay. But we're going to hopefully be here for the rest of the year on our, obviously not our usual schedule because tonight's a Wednesday. So we may be slightly irregular scheduling wise, but keep an eye on the meetup page. It will always have the correct day and time for us. But we're going to try this format out a little bit, this sort of just straight to Twitch format. If this works for you, if you like it, if it's all that, then give me let me know on the Nash Dev Slack. Reach out to our email address, pynash.organizers@gmail.com. Let us know if it's working or not. If we need to find something else, we can always find another thing. But I'm excited about sort of the opportunities here. We are recording these, so they will be pushed up to the PyNash YouTube account after this is over. I don't know sort of how long that's going to take typically, but probably give us a couple of days or so to kind of figure it out. What else do I have? I don't have a whole lot in the way of announcements. There's still a pandemic, so there's not a lot going on still. I do know that PyCon the registration is open. The CFP is closed, unfortunately, but registration is open. PyCon, I believe, is virtual this year, and the prices are significantly lower than they have been in years past, which is super awesome. And every dollar that you spend going to PyCon is a dollar that goes to the PSF and Python and everything else, and it's a good cause. So buy a ticket, for crying out loud. I have nothing else this evening, so sit back, relax, and enjoy the dulcet tones of Will Johns, who is going to talk to us about Python and how those batteries are still included. All you, Will.
Thanks, Bill. Okay, so we should be switched over now. Give me a brief moment and I will pull up my screen. Tip out of the Zoom, switch back over to my VM. I'm going to go no camera for this, mostly because that's not what you're here to see. And as Bill mentioned, I will be talking about batteries included, which is maybe an expression you've heard in reference to Python before. It's a feature of the language. And today I'm hopefully going to cover at least a couple of these things that you've not seen before. Some of them you may have seen before. But these are just some of the highlights of what's built into Python. But before we get started, who am I, right? What is my qualification to be talking about this to you today? So I am Will Johns. As previously mentioned, I've been a software developer, professional code toucher person for seven, almost 8 years now. Started off working in embedded development, embedded engineering, doing microcontrollers and IoT stuff. Touched a lot of languages along the way, but ultimately settled on Python as being my favorite. And in recent years, I've switched more into backend development, APIs and ETL work, and I'm generally happy with that as opposed to the embedded stuff. Been doing Python almost entirely full time for about 5 years, so semi-qualified to talk about it a little bit. So with that, what am I talking about, right? So what does batteries included even mean? I said this is a phrase that's described a feature set of Python, and it basically means that rather than other languages like C or like low-level languages, or other languages like C or C++, which are lower level, Python has a lot of the tools that you might want to use already built into the language. So rather than having to go out to third-party installs and seek out the functionality you need, it's already readily available for you. And then, why should you specifically care about that, right? Well, so it's sort of a double-edged sword, and you're already getting half of it. All these things being built in means that they're included in whatever images for applications you want to deploy. But by avoiding third-party installs, you can reduce your image size and just depend on what's already available to you. And you can also save yourself some time. If, for instance, you didn't know it existed and you can't find a suitable third-party library, you can avoid having to write code over and over again and then ship it around. So then, as far as how much of this I will cover, how much of the standard library I'm going to cover, the answer is basically none. I probably will not even break a percentage of the useful things available to you in Python. It's a pretty big selection to choose from. Like I said, these are just some highlights that I think are like my personal favorite that I've experienced and have some pretty common use cases. Excuse me, taking a water break. So then finally, given that I won't be covering that many of them, how can you learn more, right? How outside of waiting for somebody to talk about them at a local community meetup, how do you discover other useful Python standard things? And as much of a cop out as this answer is, the answer is just become more experienced with Python. Look around the web, keep an eye on other interesting projects. It's very cheap. It's no like one silver. There's no like silver bullet to it. But a lot of these things I've discovered, I think 2 or 3 of the packages I'm going to mention today in the last year, just from watching other people on Twitch and keeping up to date with certain libraries I find interesting and just working on like open source projects. So with that, let's get into it. As for the format today, I definitely didn't lose work and just made the decision entirely by myself to do it a bit different and do some live coding. I do have some demos for this first part, but other than that, I'm going to be sort of working off the cuff. And if you have any questions about anything along the way, please just put them in the Twitch chat and I'll be happy to answer them or go off on the tangents to fill time. So to start with, I'm going to talk about some tooling that's built in that is very useful for command line interfaces. I've spent a lot of time working on command line interfaces, both professionally and personally. I stream on Twitch regularly, and I made my own bot for this. It's actually published on PyPy and still a work in progress. But I've also done this for like ETL tooling in professional environment and other just like general dev utils. So the first part of a command line interface is obviously being able to interface with the user, which is where argparse comes up. So argparse, as the name might suggest, is a tool for parsing arguments from the command line. You can build out your own arguments. You can lost track of my notes. One second. You can build your own arguments. You can split them into submodules, so you can have like subcommands that you can nest down. You can build helps, and it's a pretty powerful tool. It's also the first thing I have a demo for, so let me switch to that. Okay, so what I have here is just a very, very light example of live coding. Like I said, I've streamed on Twitch, and I'm less scared of live coding. Like everybody makes mistakes, and everybody understands that live coding is stressful, so I'm not super worried about anybody judging me too hard here for it. And if they do, that's fine. I'll take it. Anyway, so this argparse I've got built out here is pretty light. It doesn't do anything fancy, but it's just mostly to demonstrate the functionality. So you start off by just importing the library. You can declare argument parsers inline, and the 2 notable arguments here are you can give a name for the command line tool. This is really useful if you do any kind of Python packaging. If you're going to distribute a tool out, you can actually, with argparse, declare a file and a name and then package it all up together. So I could push out a utility and then be able to like say PyNash demo and invoke it. But I'm not going to do that today. As previously mentioned, behind the scenes, Python packaging could be its own talk. As could many of these things. So, but you can also throw in a description. So I'm just going to run this with --help, which is something you get for free. So you can see the declaration there as if you would install it as a utility. You can see your help that you throw out, or your description goes into the first line of the help message. And then you get a list of potential arguments. So right now I just have one for to echo. And then if it's present, we print those out later in the process. You can call parse args to group them all together. So if we wanted to add another one, we could do who. Help is demo arg. And normally things are required, but if you define a default, you can actually skip it and make it optional. There's also option parsers, which is a separate tool from argument parser. It's a very, very powerful utility. So then if we just run this with the strict of hello world, foo is required. Foo is no longer required. There we go. Prints it out. Easy peasy. So naturally, one of the first things that comes up with this is worried about like file expansion. If you have a fully verbose tool you're writing this for, the gets to a pretty large number of lines for your code, you can actually split this out. So you can make a subparser object, add subparsers, and then you can attach different things inside of this subparser. So you can split these into separate files and modules. So you could have, like in Django, if you had an app, if you had several apps in Django, you could have their own subparsers in there and build them up to one command line tool, which is something I've worked through before. So next, after being able to parse arguments and present the user, is some formatting, which is where text wrap comes in. And this is one of the ones that I've learned about recently. So we're just going to close that. So text wrap is a utility for manipulating, as you might guess, the line wrapping of text as well as the indentation. So what I've got here at the top is just some generic lorem ipsum that runs out to 839 columns. So if I run this demo, the first thing we get is this list of lines. So what you can do is you call wrap and you can give it a number of columns that it can go out, and it will return back a list of lines where each line is at most 79 characters long, and it splits on words, which is useful, but it also has a utility built in for joining those together. So this is what fill does. I've changed my line length. But we'll jump to the next line. You can see that it prints it out as a paragraph rather than one large line. The next thing to deal with is indentation, right? Because not everything is going to be strictly left aligned. So maybe you want to preserve this indentation in your paragraph, but you don't want these leading spaces. So you can call dedent, and it will keep the interior ones, but any common white space is removed. And then say we made that decision and regretted it immediately and we wanted to add it back in twice as much space, you can call indent and provide any kind of prefix, and it will jump over that much. Text wrap was a revelation for me to understand it, trying to get text line up. Yes, it was a massive pain in the butt, and it's really useful with triple quotes. For anybody who doesn't know, say you had function foo, right, and then you declared indented inside of this. If you printed indented inside of this function, it doesn't print out with just the 4 lines of spacing here. Like you get lorem ipsum, it prints it out with 8 lines of space because it reads it from the far left because you're inside of a triple quote. So as you can imagine in production code where you get maybe 1, 2, or 3 tabs deep, that's not really ideal. So being able to dedent and then manually control your indentation is very useful. Can auto detect tabs versus spaces for indent? That's a good question. Let's find out. So backspace T, we'll rerun the demo. Maybe remove the function that is messing up our context there. There you go. So it looks like no, because the spaces are treated as a different character than the tab, then it does not remove them. It's only common. Now, if every line was preceded with a tab rather than a space, it would. That answers your question. One of the other things that I think is really neat that I did not demo here is I want to say it's shorten. It's like print lorem, no, textwrap dot shorten. Yeah. So we'll just use the original lorem ipsum with no multi-line wrapping. And then you can specify a width. So we'll say the first 20 characters. Rerun the demo. So what this does is it gives you sort of a prefix. So like maybe you want to use this, like if you're doing web presentation or like server-side rendering with Django. So you wanted to preview an article on a blog post. Obviously, you'd want to use more than 20 characters, but you can use shorten to sort of strip out just the beginning of the sentence. So it's got some very useful, very useful use cases, if you don't mind the redundancy. As you can imagine, that plays really well into command line tools. It also is pretty useful for logging if you're not using JSON logging. So looks like you can expand tabs with an extra option for expand tabs. Oh, well, there you go. Thanks, Weston. So actually, we'll open that back up. So would that be indedent then? Oh yeah, so indedent, they are not treated the same. So per the docs on dedent, they are not treated the same. So you would probably want to expand that out manually first. Can look for words versus just characters. I'm not sure I follow. I want to shorten it to the first 20 words instead of the first 20 characters. I don't know that it can. So, so you're talking about expand tabs on shorten, maybe. Break long words, fix placeholder, tab size, break on hyphens, text width, initial indent. Doesn't look like it. It looks like it only does it for explicitly width. So. Extra quarks. I don't know if there's extra quarks for dedent. But, as a quick demo, this is how you can go about learning this stuff. Yeah, dedent just takes text. So no extra quarks there. The extra quarks are on shorten. It may also be for the text wrapper. So these are utility functions that are built directly onto the library. There is also in textwrap a class for text wrapper. So the quarks are in here. So I guess we could try this out. So PW is equal to textwrap things. We'll say width is equal to 79, and we'll say expand tabs is true. Right? And we'll say print tw dot dedent. Oh, I don't know that text wrapper has a dedent function. Yeah, dedent only exists as a utility, not on the text wrap function. So final answer, no, you cannot automatically detect the tabs versus white spaces, but you could just preprocess it by replacing the tab character with white space. Today we learned. Okay, so the next thing I have, oh, too far. This one's another fun one called Schlex. So Schlex is sort of a portmanteau between shell and lexicon, like lexicon and lexing. So this one's pretty niche, to be honest. I've never run into a situation where I needed to use this one, but the idea is that demo. So we're going to run some actual shell commands first. The shell language handles argument expansion differently than Python does. There's braces, but there's also just so there's bracer expansion where you can do some pretty advanced recipes, but there's also just straight up argument parsing. So like if we run this first one here, even though these two words have quote barriers around them, it's treated as one thing. So if we do echo single quote foo, double quote bar, you just get one argument foo bar. It ignores them. And then this one's a little weirder. So you may notice that between this foo and this bar, there's double quotes surrounding a single quote. So that's how you do escapes. The shell. And so you may also notice that even though potato and tomato have their own single quotes, they're treated as separate arguments. So we get one argument with a single quote escaped between foo and bar. We get potato, tomato, baz as three separate arguments. So what we're going to do now is I'm going to run this flex demo. And so the first thing I'm doing is just doing split off of double quotes foo, double quotes around potato, tomato, and then buzz. And you see that you get a list where you have foo in double quotes, but then you have potato with a single double quote, tomato with a double quote, and then buzz. The Schlex module, so this is what we're going to do on the next line, is we're going to run that same split command, but we're going to run it on Schlex, or with Schlex's split, rather than with the default string split. You'll see that we do get foo, potato, tomato inside of single, and then buzz, and there's no double quotes around any of them. So not only does it does space separation, but it groups by the quotes. We can also do this in the inverse. So that's what this quote function will do, is given a argument string, it will return back how you should present that to a shell parser. So we can see that we escaped a single quote here. So we get a string of double quotes foo with the escaped single quote, then bar, then potato, tomato, then buzz. And then for my final Schlex trick, there's join. So you can take together multiple arguments and then join them back together. So this would all be one. So we're going to quote out foo bar baz with double quote separators and then potato, tomato. And you get this wonky looking thing of escape quotes. Like I said, this is a pretty niche one. I've seen this typically used with parsing lines out of configs in like shell scripts or in code generation for shell boilerplate. Doesn't happen too often, but whenever it does happen, having the Schlex parser available to handle all this expansion for you is very useful, and vice versa to be able to parse it back in. Again, the only time I've seen this come up is in command line tools, so that's why it's under this section. Next, we have curses. So I'm going to kind of cheese this one a little bit. The demo I'm going to use, is on my stream repository for the bot I mentioned earlier. So curses is a library for doing a bunch of manipulation for terminals across multiple operating systems. So you can sort of write once and run wherever you need to. There are a couple of exceptions there because there's so many OSs to support, but it's pretty powerful and as such pretty advanced. So what I have here, this is what I use for printing out chat on the chat bot I use normally. You have to register a cleanup function because what you're going to end up running into is you have to initialize the screen and it basically takes everything over. And then you have to redraw the screen constantly. And you have to enumerate and worry about your width and your height for your size of your terminal in case it gets resized and redrawn. But what it does let you do is you can draw anywhere on the terminal and you can color them. So it's a pretty powerful tool and you can get deep in it. It's actually, if you go to the Python documentation for curses, it has its own how-to that is going to explain it much better than I can. the mention of like some of these modules could have their own library. This is, or have their own presentation. Cursus is one of them. It's pretty deep, but it's also really, really, really useful. Oh, you can also control like blinking, bolding, dimming, reversing, anything that you could imagine stylization wise for the terminal. You can get in there. I think that's all I have for command line tools. So one thing I did want to mention is that with these command line tools, there are third-party like packages that handle a lot of the stuff for you. So the first things that come to mind are Click, which is part of the Palettes project, which is specifically aimed at command line tools, and then Prompt Toolkit, which is a bit more verbose and advanced for terminal manipulation. So you can do like split window panes, and you can do like toolbars at the bottom and key actions. So those are definitely third-party options if you needed to get more advanced past these. However, there are limitations to them. So, like one of the big ones I ran into, and the reason I'm using Cursus in the chatbot is Click has a built-in list of colors you can use for text stylization. You can't pass in your own, and I just wanted to be able to use any of them. And then Prompt Toolkit is a bit of a heavy hammer for just printing out chat. So. Yeah, Click. I think Click, one of Click's demos is actually making a Git CLI tool. I've never used DocOpt. For simple CLI apps, I just go straight to argparse. And honestly, like since I've learned out how to do, so actually, I guess I have it pulled up here. So I mentioned earlier that you can have nested modules for argparse. So for instance, I have this list of parsers, and then in my init.py, I just have a decorator that lets me declare new parsers. So I can just like tag blocks of code and build out subcommands. So ever since like getting into this, this is my go-to for simple CLIs. The Cursus thing I broke into because I wanted to change how it presented to the user. But yes, Prompt Toolkit and Click are great. DocOpt is endorsed by Bill, so it's obviously also great. I'll have to check that out after stream. Okay, so that's it for things that are sort of specifically around command line interface things, just because I feel like it's one of the more underutilized spots for the standard library. The next thing I'm going to move into is generally useful tools. So these are things that are not unique to one specific body of work like command line interfaces. FastAPI also has one. Oh, I have not checked out Typer either. I'll add it to my list. FastAPI is great, so I'm interested to check that out. But these are also things that you may use in just like general web apps or for ETL work or anywhere along the way. So I'm going to start with func tools. So I'm specifically going to deal with a couple of things inside of func tools. And this is where my written demos run out that I definitely didn't lose work for early. So I am going to resort to dealing with the Python documentation page. So func tool, go ahead and get it pulled up. The things I want to talk about today are LRU cache or cache, wraps, and reduce. So you may have heard the term memoization before. Basically, it just means that if you have some process that you're going to run over multiple times, rather than recalculating the same result multiple times, you cache the result for a given set of arguments. And then if you receive those same arguments again, you just have to return it. So factorial is always the one that comes up. So like if you calculated factorial of 6, you have to do 5, 4, 3, 2, and 1 along the way, right? And so if you're calculating the factorials for 5, and then you want to calculate a factorial for 6, rather than redo all of those multiplication steps again, just pull the answer for 5 and then multiply it by 6. So rather than writing your own caching method, which usually involves a dictionary, you can use @cache. So you can just import this from functools. A way to do that would be, so we're going to move straight into just straight up REPL. So you would do from functools import cache. And then you can do an @cache decorator, right? And I'm just going to print through. I'm not actually going to write out factorial and make you guys watch me suffer through that. But then what it will do is it will handle the memoization of results for you for that function. There's also in the same vein, so the LRU cache decorator, the only difference between this and cache is that LRU cache lets you specify max size. So maybe you don't want to keep every result, but like maybe you wanted to keep the last 12 of them. You can specify max size, and that way you avoid sort of a memory expansion. Is it a kind of const expr, but for Python? Oh, typer? Okay, you're pointing up, so I'm assuming you're not talking about LRU cache or anything else I've covered. So I'll keep going. So it's really useful for any kind of like CPU intensive processes you're going to repeat multiple times. Factorial is the default example, right? The next one is wraps. So while we're here, let's go down to wraps. So you may have noticed that LRU cache and cache are decorators. So functools has this utility called wraps, which makes writing decorators cleaner, in my opinion. One of the key things you get here is that it preserves the doc strings. So normally whenever you decorate a function, you don't get the same documentation back out of it because the object returned is entirely different. The wraps decorator builds partials around the wrapped function, so you get the same doc string. So that's what this demo here covers. If you did this with just a normal decorator, this doc string here would not be preserved because it's a new object. So if you ever have to write any decorators, as mentioned earlier, I use one for declaring new parsers and submodules. Wraps should be on your list of known functions. And then finally, the one I use the most out of here is reduce. So reduce is pretty straightforward. You give it a function that takes 2 arguments, and then it will call that function repeatedly over a list of in an iterable of an object and apply it to each of them. So the example they give here for summation, right? So if you call lambda xy, sum them together, or an array 1, 2, 3, 4, 5, this is what it evaluates to. So it just reduces an iterable based off the function you give it. This has a ton of applications in a lot of places just because you can pass in custom functions. Guess what I could do here? Split this into a different screen, present here. There we go. So next is collections. So this is another one that's got a ton of stuff in it. The things that I wanted to mention specifically are name tuple, dequeue or dec, order dict, and default dict. And I'll probably do a live demo for default dict here. So name tuple, see if we can just go with their example. Yeah, so it's sort of a shortcut for creating a class with like specific attributes and nothing else. Data wrapper class, right? So you can just say point is equal to name tuple. You give it the name of the class you want to use, and then you provide attributes on it. And then you can use it as you would a class for declaring and holding data. But also you can access the functions at the given indices. And then you can use the attributes off of it. Dequeue is another one I'll just demo in here. So dequeue is a doubly ended queue. So it's similar to a list, which is itself sort of a queue, or more specifically, the actual queue object in Python. But it works from both ends. So rather than be able to pop off of one side only, you can pop off of either side. Yes, data classes are also great. Name tuples are. I feel like it's fair to say name tuples are data class light. So you can append left, and then you can pop and pop left. So you can operate off of both sides. And it's pretty efficient in doing so. Very useful if you want to be a little bit more explicit about which end of your object you're working off of, but you do want to work in order. It's also, this is super useful if you get into like interviews. This is one of like the utilities that comes in handy more with like interview questions or like code challenges than it does in real life situations, in my experience. Name tuples are hipster data classes. Yeah. So then ordered dict is another one. The last one I'm going to talk about. Oh, ordered. Can't spell. Ordered dict is one I want to talk about using this documentation. Yes, the name tuples are immutable. So ordered dicts are, as you imagine, dictionaries. However, one of the key differences is that they remember the order in which things are inserted. So you can build them off of a list of items, and then you can access them incrementally and not worry about it being out of order. So I think this is less of a problem. I want to say as of Python 3.5, maybe 3.6, the default dictionary retains the order of objects as you're inserted into them. So depending on which version of Python you're running on, this may be less of a useful thing. But for all of the cases, order dict definitely does. And you can access dot keys and they return 3.6 is order. Okay, yes. So 3.6 and onwards, this may be less pertinent to you, but anything prior to that, it's super useful. There's also some additional additional methods that are built on top of order dict that don't have, like, they don't exist in the default dictionary, like move to end and reversed. But so then finally is default dict, and this is where I'm going to pop into live coding because I think this one's super useful. So from collections, import default dict. So the way this works is, normally if you have an empty dictionary and you try to access a key inside of it and it doesn't exist, you get this error for key error, right? Well, what if I told you that with default dicts, you can provide an initializer? So like say we wanted it to be a default dictionary of integers, right? Then if you try to access, so we'll say just print it out real quick and you see that it's empty, right? Now if we try to access get A, we do get back 0 instead of a key error. So you can provide a default initialization. And it just takes any function, any factory method. So like we could do list, right? We get back empty list. You can also write your own. So we could do lambda. It's going to take no arguments and it's going to return back a default dict of integers. So now if we say get A, oh, what did I do wrong there? They changed the way this worked in 3.9? Oh, okay, there we go. So now if I access that and get back another default dict so I can go even deeper, now I can say D at A of 1, and there it is, right? So it's very useful. 3.7. Ah, okay. So default dict, as you can imagine, has a lot of like good uses, especially for being able to avoid like writing code that avoids exceptions, like in handling our use cases. Now, one of the things you can run into here is that you may like maybe you want an error out. Can you use strings in there, like in the default dict? Yeah. So the case I'm demoing here with lambdas is if you can make it a generation function, you can use anything in here. So if you're asking like, can you just specify string as the default operator? Yep. You just get back empty string. So Um, you can make it anything you want to. So it's very very useful, especially if you have like a dictionary of custom classes. Like you could even make a lambda that return a custom class iteration, so you could like default users. So that's why I wanted to demo that one. Default dict is really cool. Probably the wonkiest use case I've had of this was for Advent of Code, and it basically was a code challenge in which you were operating under an assumption of an infinite space, right? So if you ever have seen Conway's Game of Life, right? Uh, Creating a default dict of objects that represented a cell made it very easy to just sort of handle the logic to expand outward infinitely. Yes. Yeah. So that was my point I was working towards, is that it's great for avoiding errors until you don't want to avoid errors. Let's see what time we're at. 6:51. Okay, I'll try to move this along. Okay, so next is URL lib. So I'm sure that at least most of us are familiar with the request library, right? Well, what if you didn't need to use the request library? So Python has built-in URL lib, and you can use this and avoid installing that massive library to do all of your HTTP requests, right? So you can give it a URL, you can give it data, so you can do gets and post inputs, and whatever you want to do. You can specify headers. It has these request objects you can build out. So there you go, headers, origin request host, methods you can specify. Uh, you can do anything you would need to do with interacting with the internet straight out of the box. So I know several people who prefer not to use requests and instead just use the URL lib and have removed that from all of their projects. And you can get all the data back out of it. You can do the encoding and parsing. So this one I'm going to sort of skim through just because it is pretty deep. It used to be, actually, one other thing I want to mention is that it used to be URL lib 2 here. So it's been renamed as just URL lib now. Yeah, so like that's the one thing I've seen people like. I have seen people default to request because it has a nicer interface, but just install the library. I don't know that it's bundled, but request is a pretty big library to install. So that's one of the reasons I've seen people use URL lib, is you avoid a pretty weighty add. And also from personal experience, I don't think the interface is terrible. Yeah, so I don't think it's bundled. And per Guido, like the last quote was, the reason request is not bundled is because request updates much faster. So Python's on an 18-month release cycle. Request is much more frequently updated than that. So after URL we have subprocess. I'm actually going to go ahead and reveal the next one too, because they sort of go hand in hand, multiprocessing and concurrent futures. So subprocess, boom. So the key ones here are spawn and popen, which is process open. You can open subcommands to the host operating system. So working with IoT devices, this is pretty useful because maybe you need to interact with the USB bus, like the LS USB. Just curiosity, how constrained in space are embedded developers nowadays? It depends. So I know the Pico probably just released, right? It's probably still sold out everywhere. But like just to use this as an example, it's got 246 kilobytes of internal RAM and 16 megabits of off chip flash. And they definitely do get smaller in this though. So how constrained embedded developers are sort of is a loaded question, because you could go all the way down to like AT Tiny 85. So AT Tiny 85 has 8 kilobits of memories for program. So pretty low. Depends on what sort of IoT device or what sort of device you're working with. But you can also get pretty big too. Okay, so subprocess lets you open up commands to the host process. So listing directories, like there's a way to do this directly in Python, but it's also oh man, I would love some MicroPython and PyNash. You can also like access other things. So maybe you wanted to invoke a Java library you had installed, right? You can invoke that directly from a Python script with subprocesses. You have a PicoPy? I'm jealous. Everywhere I've looked, they're sold out. I would like to add like a dozen to my collection. You can also get the output back in directly. So by default, it just opens it up, fires it off, and keeps going. But you can capture output, in which case it will block and it will return whatever the host operating system returns to you. So you can see here that you get return code and the results. Very obviously very powerful because you can invoke anything on your host operating system, but it makes sort of cross functionality between Python and other things much more feasible. Another thing that I brought up is multiprocessing, so / concurrent features. So I may have heard of async IO by now. It's one of the big things that was added to Python recently. Async work is great for things that are considered what's IO bound, right? They are restricted in how, like, so if you have a list of 10 tasks you need to do that are IO bound, they will operate as fast as you can receive input and output. So asynchronous operations are great for them because then you just sort of do something else while you're waiting for the input or output to return. Multiprocessing opens up new processes. So these are great for things that are what's called CPU bound, which is sort of a hardware limit. So most modern computers nowadays have multiple processors, right? Multiprocessing lets you take advantage of those. If you don't know, Python by default is singular process, and then threads. If you open up new threads, like with async or the threading library, they open up on the same process. So you're really only ever getting like one core. So if you have an 8-core machine, you have 2 logical cores per machine, you have 16 total processors. By default, Python will only run on one of those, no matter how many threads you open up. Multiprocessing lets you open up new processes across them. So rather than a single like 3.6 gigahertz process, you can get your full 16 3.6 gigahertz processors, which you can probably imagine a 16 times improvement in CPU could be useful. Now, for the previously mentioned I/O things, like if you're doing a bunch of web requests, that doesn't particularly help you. You would get the same effect using threading versus multiprocessing because you're mostly waiting on the internet to respond. But say, for instance, you were doing a bunch of like database operations, right, on your local machine. Like you're not waiting for any input output because you've got an NVMe drive. It's super fast. Opening up multiple workers with multiprocessing, which is pretty straightforward. You can create a pool of them. You can specify how many you want to use, and then you can just map over them. And the API for interacting with this is very similar to threading. You can open up a bunch of processors, and it's fantastic. If used appropriately, this can give you a lot of performance increases. Now, I mentioned multiprocessing, but there is also Python concurrent futures, and this is sort of where multiprocessing is going. So this is executor and threadable executors, and you can do process pull executors, sort of a merger of the two in under one library name. So here you go. This is a great example of calculating whether or not a number is prime, right? It's a very CPU intensive process to determine whether or not a number is prime because you have to perform these cyclical operations over it. So you can just open it up in a pool, and rather than doing this one, then do this one, then do this one, then just do this one, you just do them all at the same time. Yeah, so Python is very powerful. Like if you okay, so I think someone said it best. What is it? PyPy? if you want to have faster code, just use PyPy, and it will magically be faster. So, oh, there you go. Yeah, if you want your code to run faster, you probably just use PyPy. Guido von Rossum, right? Now, caveat: not everything runs on Python or PyPy, even though it is 4 times faster than CPython. It only is released up to 3.7, so you don't get that sweet walrus operator yet. Jython, I think Jython also still only supports 2.7. There's also Iron. We're on a bit of a tangent, but that's okay. Yeah, there's Iron Python, which supports Python 2.7. I don't know what version Jython's up to. Also 2.7. So you don't want to use either of those because they support a Python that's no longer supported. Okay, so concurrent features / multiprocessing and subprocesses let you get access to basically your full machine. You can open up other operating system commands and you can use all of your power. You paid for the whole computer, might as well use it. So then honorable mentions. These are the fun ones, and I know we're at 7, so I'll try to get through them. Bisect. So this is another one that if you're in a programming interview, a technical interview, and you ever need to do a binary search, bisect is great if you can get away with using it. So import bisect. What bisect does is it lets you bisect. So if you ever use git bisect, same way, it lets you bisect or perform binary search, binary-like operations on assorted things. So say you have a list of 1, 2, 3, 4, 10, 100, right? You can say bisect L, and then, so I think it's the array and then the thing you would want to insert. So this is a sorted list, and if I tell Python that I want to insert the number 15 in this inserted list, what index do I need to put it at to keep it sorted? It tells me index 5, right? So I'm going to say L.insert, I think it's index then number. Say L, boom. So it goes in an assorted place, right? It's very cool. In fact, it's so cool that there is insort. So let's say 12, right? So now 12 is injected in there. So we have direct access to it. There's a bunch of like very useful things on here. So bisect left, bisect right, insort left, insort right. And it's pretty efficient as far as things go. I think insort is O of N because it still does insertion. I think it still does insertion at O and N. So the actual bisect, this process here of getting the index of it, is O of log N because it is binary division, right? So let's say import random. We'll say L is equal to a list of random dot rand int between 0 and 10,000. Yeah. Or I in range of 10,000. I'll just do it. Yeah, we'll do 10,000. Right, and then we'll say L is equal to set of L, length of L. So the 6,360 is what we ended up with. I think we can still do bisect on what's the list? 12. Oh, it doesn't. L is equal to list of L. This is a roundabout way to get to this. Oh, I did insert. Whoops. Let's look at the first 100 numbers. So we'll do 157 because it's not in there. Also, I put 12 in without checking if it was in there. List of set of L. Okay, so L dot bisect of L 157. So we need to put it at 96. Okay. Anyway, so it's super powerful. Runs over all languages or all manner of sizes and stuff. Pretty good. Understanding the data structure, is it a tree or a sorted list? So bisect doesn't have any underlying data structure. The list has to be sorted, yes, because It's just binary division. So binary division has to work with the sorted data object in any case, right? So if you just had a generic tree, in order to do binary navigation, you have to have it sorted because you need to have information about whether branching left or right is towards your objective. So like one of the human parsable examples is phone books, right? Phone books are sorted list. Like if I was looking for John Smith, like I know that I can jump and I open it up to a random page and I'm at M, right? I know I need to go to the right. I need to go towards the back. Yes. So, and again, to reiterate, it's not that it's bisect doesn't have a data structure. It just operates assuming a sorted list. So Python bisect. It is array bisection algorithm. No idea. Boom. All right. Mission accomplished. This past hour has been worth it. We showed somebody something new. So it also has got some really great examples in here. So it has like how-to code for like if you wanted to index something or if you wanted to find the rightmost value less than X, right? So all of these things are like very common interview questions. And it's got examples on how to use them. It's very, very cool. Yeah, so this is why I wanted to bring it up under honorable mention. One of the other things too is that if you minimize this, I'm going to type import bisect down here because I want to be able to jump to it. So if you jump to the actual source code, it has some rough, like high-level algorithms of how they're doing this. So even if you can't use it, you know where to find it, right? Like if you have access to a computer, you can't use bisect and be like, oh, here it is. I didn't use Google. But I mean, if you get too cheeky with your interviewer, prepare to not get the job. Point is, it's there. So you may not be able to use it directly in binary search, but if you can find like binary searching through things is a pretty big crux in a lot of interview questions, like code challenge-y things. Yeah, mention that you would use it and then don't. But also if you're dealing with like a more complex thing, right? Like if you're dealing with custom data structures, if you're dealing with custom data structures and you're dealing with like more complex operations, you can sort of coerce yourself into a position where you can use bisect, right? So if you didn't know, if you have class foo, right, you can define, I think it's LE. No, it's GE for sure. You can define functions, self and object, for how custom classes do comparisons, like am I less than or greater than this thing, right? So if you have a custom class and you can get it into a list, you can then use bisect on custom classes. It doesn't have to just be a standard type. So like I said, if you get to a more complex interview question, bisect can still get you there, and that might be an allowable situation. It might also not. But either way, big ups for it being there. Or if you're doing code challenges, like on LeetCode, or anything else, like it's obviously helpful. Linear searchers are not going to try and flip around implementing a binary search in a quick coding screen with way too many edge cases here on. Yeah. And I think it's a lot of like mileage may vary, but dim dunder methods, there are a lot of them. You got what, EQ, you got hash, and honestly I think hash is an underrepresented one. Yeah, less than, I think you just have greater than. I don't think all these are defined because I think if you have equals and some other one, then like that's all you need. You got repr, right? There's a few. Okay, moving on. Well, I think this is either the last one I have or the second to last one. So this is context lib. I think it's the second to last one. So context lib, if you've ever used a with block, so you'll say like with open foo.text as f. So this is a context manager, right? Context lib lets you create your own context managers. And the TLDR of what this does is it performs some operation at the beginning and end of this nested block. File management's a big one because you have to open and close the file. So like that's why it's built in directly. But if you had like some custom handler you wanted to wrap around, or error handling or state preposition, Context lib lets you make context managers for those. Context lib. So it doesn't come up very often, but whenever you can, like whenever you do need it, it's super useful. So like here's an example, manage resource, right? So like you want to try and yield the resource and then finally do this other thing. And then now you can say with manage resource and wrap it around there. So it's pretty straightforward, but like I said, it's whenever you run into it, it's great. There's also async content managers. So this one's probably one that if you were going to use, I would recommend reading through the documentation on it before you dig into it. And the last one I have is temp file. So this is another one of it doesn't come up all the time, but whenever it does happen, it's super useful. So I only have used this with test code. So temp file, as the name implies, lets you create temporary files. You can also do name temporary files, temporary directories, split temporary files. So if you're trying to test some code that manipulates files on disk, you don't want to actually create those files and then keep them in a temp space, right? But you can patch over what file is being used and then use temp files to create them, manipulate them, and check them during your test. I don't think they have any examples on this page. Oh, here they do. So you can create a temporary file, you can write to it, see to it, read to it, do anything you want to do, treat it like a normal file, right? And then whenever you leave the Python REPL, right? So like you have quit here, the directory and contents that you created with temporary directory and temporary file are gone. Poof, vanished. So it's very, very useful. Use this with PyTest a lot. And that is all the ones I had to mention today. So like I said, there are way, way more tools in the standard library. These are just sort of some icing on the cake ones that I've either been aware of or used in some real life situation for me so far. I do encourage like trying to be familiar with it. There was a tweet a couple of years ago that went out where people were asked like how much of the standard library they felt like they knew, and nobody answered 100%. I think the most confident answers are like 70%. It's huge. So don't be afraid to get in there and dig around a little bit, right? If you just go to the Python docs homepage, right? Library reference, like there's a ton of stuff in here. Cryptography is another big one, right? Context variables, internationalization, right? Just get text and locale. POSIX, print direct. Oh, shoot, there's another one. This one, I want to point this one out. This should have gone in my honorable mentions, but it didn't. Here it is, disassembler. There is a disassembler for Python. So if you're ever curious of like what is actually happening under the hood of the Python code you write, Python has a built-in disassembler that like tells you what opcodes are being ran. It's pretty crazy. It can definitely be intimidating if you don't quite understand the concept it's working with, but for like performance analysis, for like micro optimization of code, this is really useful. It's just a fun thing to have included. So yeah, I am. I'll own that badge. Today you learned text wrap, bisect, concurrent features, all gold. Glad to hear it. They're amazing. AST is another great one. Okay, so like I said, there's a ton out there. Feel free to go dig around a bit. You may be surprised at what you can find. But if anybody has any questions, I'm happy to answer them. If anybody has questions for not me, if you want to bring Bill back on, that could also probably be arranged. Provided he's not like 17 cocktails in after having to sit through me. Otherwise, I think, as Bill mentioned, we're going to try and keep these regular. If this is a format you like, be sure to mention it in the Nash Dev Slack. I will be only 1.5. Okay. Whew. Good call. This has been recorded. I will be uploading this up to YouTube. It also will be on Twitch as a VOD, video on demand. So you can just come back to this channel, click videos, and it'll be there if you want to watch the raw. I'll try and take this and trim out some of the fat before I upload to YouTube. And then hopefully